Okay, I'm going to go through a brief walkthrough on how to complete this problem for Hardy-Weinberg. Okay, so for this first part, it talks about how we're going to be looking at hair type. Straight hair, curly hair, wavy hair. It's governed by a single pair of alleles, and we're talking about pair of alleles. When you have straight hair, you're homozygous for the S allele. When you have curly hair, you're homozygous for the C allele. And when you have wavy hair, you're heterozygous with the S and C allele, right? We know that we inherit 2 alleles every single time, and that's going to be associated to our phenotype. This first part up here tells us a population, what type of hair they have, and how many are associated to that. And as a reminder, each of these individuals are going to have 2 alleles, and so that's going to help us complete this chart down below here. So if we know that there are 245 of them who have straight hair, we're going to be working off of this row here for straight hair, and that's associated to the S allele. Each of those individuals are going to have 2 S alleles because they have straight hair. They're homozygous dominant for that allele. So that means if we want to know how many S alleles they have, we're going to take their total population and multiply it by 2 because we have 2 S alleles involved here. So 245 times 2 should give us 490 total S alleles for the straight hair population that we're given. There are no C alleles in straight hair, so we would have 0. When we look at our wavy hair population, there are 362 with wavy hair. Wavy hair is associated to half the alleles being straight and half of the alleles being curly. So that means there would be 362 alleles associated to the S allele for wavy and 362 associated to the C allele for wavy hair because they're getting one of each. And then our last one is talking about our curly hair population, which is 393. Sorry, that didn't like my circle. And that's associated with curly hair. Again, curly hair does not have any S alleles. They each have 2 C alleles. So if we multiply 393 by 2, we should end up with 786 for the total alleles. Now what I'm going to do next is find the total amount of my S alleles here. So when I add those together, I get 852. And when I add these together, right, I end up with 786. These are total alleles. These are not frequencies yet. So by doubling everything up, instead of having, 1,000 as my total here, down here in my chart, I now have a total of 2,000 because I know there are 2 alleles associated to each person. So when I find my frequencies for P and Q, I'm actually going to take those totals and divide by 2,000, which represents how many total alleles are found within this specific population set that I just went through. So to find my frequency for P, and I do this calculation, I should end up with something like 4.426. And then this should be something like, I think, 574. And again, if you know P, you can find Q by taking 1 minus P, and that should also equal the same thing over there. Okay. So that's my first part. I'm going to use some of that information up top again. So if I go through, when I go to my chart, my observed, I'm going to see if this population is in Hardy-Weinberg equilibrium. I'm going to use the observed information from up here in that chart, right? So And I'm going to list these in frequencies so I keep it pretty much the same thing. So if I had 245 individuals with straight hair, when I find that frequency, that's the same thing as 0.245, right? And the wavy hair would be 0.362 as a frequency, and curly would be 0.393. All of that is going to add up to equal a total of 1. When I need to find my expected information, I'm going to be using my Q, my P, and my Q calculations, right? Because straight hair is associated to P squared. This wavy is going to be our 2PQ, and then curly is Q squared. So when I do that, I'm going to take my P squared, or take 0.46 and square it. And then when I solve for my wavy, I'm going to take 2 times my P and Q. Okay? Figure out what that's equal to, and then my other one is Q squared for curly, so I'm going to take 0.574 and then square that. And that should give me my expected values based off of my allele frequencies that I completed in the chart above. And then from there, I can go through and complete the rest of my chi-square. I'm going to be working off of, once I get that, I'll have a final value by adding up all 3 of those once I get there. And then I'm going to be working off of this confidence level right here. And if the value is larger than that, then I would say that the population is not in Hardy-Weinberg equilibrium. If the value is equal to or less than that, then I can say that it is in Hardy-Weinberg equilibrium, or the population is not evolving. Okay? Let me know if you have any questions.